10 quintillion years into the future, the ultimate journey today. We're taking the time machine on its longest voyage yet. 10 quintillion years ahead. That's a future where the universe will be almost unrecognizable. Stars will be long gone. Black holes will have risen and faded, and Earth will be nothing more than an ancient footnote. But what will actually happen out there? And could humanity, in any form, make it that far? First, how far is 10 quintillion years? That's a 1 followed by 19 zeros. 10 billion billions. Big enough that your calculator would laugh at you. It's so massive we couldn't even fit all those zeros neatly on this page. But don't worry, we've got a lot of cosmic ground to cover before we get there. 1 billion years from now, Earth's last breath, jump ahead just 1 billion years, and our blue marble is unrecognizable. The sun, warming about 1 degrees Celsius every 100 million years, has turned Earth's surface into a furnace. Average temperatures hover around 47 degrees Celsius, 117 degrees Fahrenheit, hot enough to collapse the carbon cycle. First, plants vanished, then animals. Any survivors clung on in the oceans, until the oceans boiled away. What's left is a dry, rust-colored rock drifting silently through space. If humanity survived this point, it's only because we left long before it happened. Mars wouldn't save us. It would be scorched too. We'd have needed to build colonies far from the sun, maybe even in other star systems. And by now, Mars, if we ever did colonize it, would be as lifeless as Earth. Some humans might have abandoned biology entirely, uploading their minds into machines. But even digital immortality still needs energy, which means real humans would be out there maintaining infrastructure to keep their virtual descendants running. A note on energy, no matter which future humanity chooses, physical or digital. We all need monumental advances in power technology. That's why companies like Hillcrest Energy Technologies matter today. Their cutting-edge ZVS inverters boost energy conversion efficiency to a staggering 99.7%, saving enormous amounts of power. They could slash EV battery costs, improve renewable energy systems, and power the kind of interstellar civilization we'd need to survive billions of years. 10 billion years. Farewell to the sun. Fast forward to 10 billion years ahead. The sun has burned through its hydrogen, swelled into a red giant, and shed its outer layers, swallowing Mercury, Venus, and likely Earth. All that remains of our planet is a lonely iron core. The sun itself has shrunk to a white dwarf, small, dim, and cooling. Meanwhile, the Milky Way has collided with Andromeda, forming a new galaxy. Our solar system might be flung far into the outer reaches, or ejected entirely. But humanity wouldn't be here to see it. We'd have moved on to safer territory. 22 billion years. The Big Rip. Some cosmologists think dark energy could tear the universe apart in about 20 billion years. If so, galaxies, stars, planets, even atoms would be ripped away from each other until nothing remains. Fortunately, that's still a theory. If it doesn't happen, We move on. 100 trillion years. The stellar graveyard by this point. Star formation has stopped. All that's left are the faint glow of red dwarfs, the fading heat of brown dwarfs, and the silent corpses of neutron stars and black holes. The stelliferous era, the age of stars, is over. The universe has run out of hydrogen to make new ones. 10 quintillion years. The degenerate era begins now we've arrived. The cosmos is dim and quiet, populated only by stellar remnants. White dwarfs, brown dwarfs, neutron stars, black holes occasionally. Two remnants collide, maybe sparking one last star or a supernova. But for the most part, space is getting darker and colder. Matter itself is starting to decay. 10 decillion years. The death of protons. Proton decay slowly unravels the matter that makes up everything. Even the last white dwarfs fade to a faint glow before disappearing entirely. 10 duodecillion years. The black hole era, only black holes remain, devouring anything that wanders too close. Over unimaginable time scales, even they evaporate via Hawking radiation, releasing tiny bursts of energy before vanishing. A Google years. The dark era, the last black hole dies. The universe enters its final act, cold, lightless, and almost empty. The few particles left are scattered across unimaginable distances. This is the Big Freeze. Infinite expansion. Zero new energy sources. Temperatures just above absolute zero. Or the Big Crunch. Another theory says expansion might someday reverse, collapsing the universe back in on itself. That could spark another Big Bang, restarting the cycle. But current evidence leans toward the endless expansion of the Big Freeze. The only way forward life as we know it needs stars. Once they're gone, so are our habitable zones. Our only hope might be to engineer our own universes, crafting new cosmic habitats from scratch. If humanity ever advances to a Type 7 civilization, we could reshape reality itself. Until then, the clock, or rather the universe, keeps ticking.